In this video, we're going to look at how to solve polynomial functions by factoring. And I've got several different types on here. I've got some where all you have to do is take out a GCF, some where it's sum or difference of cubes, difference of squares. I've got all kinds of different types. And if you don't remember how to do certain types of factoring, again, I've got a video over how to factor different types of polynomials. So first, when you go to solve by factoring, you want to make sure it's equal to 0. Next thing you do, look for a GCF. After you look for a GCF, factor if possible. Most of the time it will be. Then you solve each factor for 0. So looking at this one here, I need it equal to 0 before I begin. So I have to subtract 3x squared from both sides, which is going to give me 4x cubed. And again, we're subtracting 3x squared. So negative 3 and negative 7 give me negative 10x squared. Then you look for a GCF. In this case, 4 and 10 are both divisible by 2. X cubed and x squared are both divisible by x squared. Now remember, when you're taking out a GCF, basically you're dividing both of those terms by that factor. So 4x cubed divided by 2x squared will give me 2x. And then 10x squared divided by 2x squared gives me 5. Now after the GCF, look to see if you can factor further. If you can factor further, do so. Monomials aren't going to factor further. And if you have x to the first power like we do here, that's not going to factor further. So we're done factoring. Now what you do is you take each factor, set them equal to 0, and solve for x. So on this one, if I divide off the 2, I get x squared equals 0, square root, and I get 0. On this one, add 5 to both sides to get 2x equals 5, divide by 2, and I will get 5 halves. So these are my zeros, my roots. Remember, zeros, roots, solutions, x-intercepts, these are all terms that mean the same thing. Alright. The next one. Again, first step, make sure it's equal to 0. So I'm moving both of these over to the other side. I'm going to add 9x to the 4th to both sides, which gives me 10x to the 4th. I'll subtract 13 from both sides to get negative 10. Now on this side I have 0 left over. So this one, again, next step, GCF. GCF is 10. So I have x to, take out the 10, I'm left with x to the 4th minus 1. Then look to see if you can factor, and we can on this one. X to the 4th and 1 are both perfect squares. Remember that any even exponent is a perfect square. With the difference of squares, you square root both terms. You can bring down the 10. Square root of x to the 4th is x squared. Square root of 1 is 1. So you do x squared plus 1 and x squared minus 1. This one is also a difference of squares. So factor further. X squared plus 1, you can't do anything. It's addition. And the pattern is difference of squares. So we can't do anything to that one. But we can on this one. So square root of x squared is x. Square root of 1 is 1. So I do x plus 1 and x minus 1. Now this is factored further. Okay, so what you want to do is you want to take each factor and set it equal to 0 and solve. Now this 10 is not a factor. If I try to take 10 and set it equal to 0, I'm not going to have anything but a false statement. There's nothing else I can do. So ignore the 10. X squared plus 1. I'm going to set that equal to 0 and solve. X plus 1 and x minus 1. I'll set those equal to 0 as well. On this one, I start by subtracting. Subtracting 1 from both sides, which gives me x squared equals negative 1. Then I square root both sides. Now, square root of negative 1 is an imaginary number, so it's plus or minus I. So that is one of my answers, one of my zeros. For this one, I subtract 1 from both sides to get x equals negative 1. There's a second answer. And for this one, I add 1 to both sides to get positive 1. That's my third answer. Or technically fourth answer, because plus or minus, that's two separate answers. Alright. Now, again, to recap before we move on, make sure it's equal to 0, look for any GCFs, factor completely, then solve each factor for what x value gives you 0. Now, you might notice that I had a square root on this one. If you are struggling on simplifying square root stuff or solving by square roots, you might want to go back and review that. Now, this one is a difference of squares. The first one I did, all you had to do was take a GCF. The second one I did, this was a difference of squares. This third one is a difference of cubes. It's a difference because it's subtraction, cube because x cubed and 216 are both perfect cubes. Now, one more thing, I'm not going to do a separate example with sum of cubes, but you work it pretty much the same way. Alright. So for a difference of cubes or sum of cubes, you start by cube rooting both terms. Okay? And then you use that to follow the pattern for a difference or sum of cubes. For a difference of cubes, it's a minus b times a squared plus ab plus b squared. That's the pattern for a difference of cubes. So I'm going to plug x in anywhere I see an a and 6 for b. So a minus b means I have x minus 6. Then a squared, so that's x squared, plus a times b, so x times 6 gives me 6x, plus b squared, so 6 squared is 36. Now, anytime you do a sum or a difference of cubes, you'll be done at this point. You'll be done factoring at this point. So the next step you do is to take each factor and solve for that factor. The first one is usually pretty easy. If I take this, set it equal to 0, I'm just going to get 6. But the trinomial is not factorable. So you're going to have to either use difference of squares, completing the square, or you're going to have to use the quadratic formula. If you forgot how to do either of those, I have videos going over both of those. I'm going to use the quadratic formula in this one. So x is equal to negative b. My b value is 6, so that's negative 6, plus or minus the square root of b squared, so 6 squared is 36, minus 4 times a times c, which is also 36. Okay. Well, I guess I should write out the quadratic formula just in case you forget what I'm doing. Whoops, that's b squared minus 4ac all over 2a. So again, I'm just plugging in my a, b, and c values into the formula. So, okay. So now I'm going to go through and I'm going to simplify a little bit. So negative b, so that's negative 6, plus or minus. Now, when you're doing this, you're almost always going to end up with either imaginary or irrational, one of the two. So make sure that you don't, when you go to simplify, don't include the square root at this point, because you're either going to get an imaginary answer, which is going to register as an error in a calculator, or you're going to get a irrational number, which is going to be a non-repeating decimal that you can't put as a fraction. So do just what's under it and then simplify from there. All right. So to simplify the radical, what I'm going to do is I'm going to take the 108, I'm going to break it down. It's even, so I know it's divisible by 2, and it's 2 times 54. 54 is divisible by 2, that's 2 and 27. 27 is divisible by 3, it's 3 and 9. And 9 is 3 times 3. Once you've broken it down as far as you can go, broke it down to the primes, you look at the ends of your tree and find pairs. So I have a pair of 2s, a pair of 3, and a 3 left over. If you have more than one pair, you only multiply 1 from each pair. So 2 times 3 gives me 6. It's imaginary because it was square root of a negative, and square root of 3 because I had a 3 left over. Now, negative 6 and 6 are both divisible by 2. So I can simplify this a little bit further by dividing those by 2 to get negative 3 plus or minus 3i square root of 3. So with this one, 6 and this were my answers. Now, I just did a difference of cubes. I'm not going to do a sum of cubes example, but you work it the same way. You'll have one like this where it's pretty easy to solve, and one where you're going to have to do either quadratic formula or completing the square. So I'm going to move over to trinomial examples. This one's a trinomial example where our a value ends up being equal to 1. I know it doesn't look it right now, but that's because I have not done step 2 of solving, which is take out a GCF. All 3 terms are divisible by 2 and by x squared, which will leave me with x to the 4th minus 5x squared minus 24x. I'm sorry, just 24. Now if I look at this trinomial that's left over, my a value is equal to 1. So when this happens, all you have to look at is your c value. You find 2 numbers that multiply to be your c value, but add to be the b value, which in this case is negative 5. So numbers that multiply to be 24, but add to be negative 5, will be negative 8 and positive 3. So I bring down the 2x squared. I'm not done with it. Okay. Now because this is x to the 4th, when I go to write my factors, I'm going to have x squared in my factors, not x. So I have x squared minus 8 and x squared plus 3. Now looking at each factor, this one cannot factor further. Neither can this one because 8 is not a perfect square. And then this one's addition, so I don't even have to look further. Well, I should clarify. Because this is x squared and addition, it's not going to follow difference of squares. Okay. So this means I'm going to go to the next step, which is to set each factor equal to 0 and solve. So if I take 2x squared equals 0 and solve for x, I divide off the 2 to get x squared equals 0, and then square root to get 0. Okay, x squared minus 8, set that equal to 0 and solve. I add 8 to both sides to get x squared equals 8, and then square root. Now, I am going to have to simplify this. If I take 8 and break it down, 8 is 2 times 4, which is 2 times 2. So I have a pair of 2's and a 2 left over. So plus or minus 2 square root of 2. So that's the solutions to the second factor. For the third one, I have x squared plus 3. I start by subtracting 3 from both sides, and then square root both terms. this is going to give me x equals plus or minus I square root of 3. I, because it was a negative, and square root of 3 can't reduce, so I just leave it as square root of 3. Alright, on the next example, set it equal to 0 first, so I'm going to rewrite it as, 3x to the 4th minus 2x squared minus 16. And because the a value is not 1 and there is no GCF, what I'll do is multiply 3 and negative 16 to get negative 48. And I want numbers that multiply to be negative 48 but add to be negative 2, which are negative 8 and positive 6. So when I factor that, I'm going to write this as x squared minus 8 times x squared plus 6. But I have to include this 3 because right now if I were to distribute this back out, it's not going to end up equaling what I started with. I can fix that by doing this. Now, 8 over 3, that's not going to reduce, so I'm just going to rewrite it as 3x squared minus 8. For the second one, it does reduce, so I get x squared plus 2. Alright, now solve each factor. So if I take 3x squared minus 8, set it equal to 0, I will start solving by adding 8 to both sides. The next thing I have to do is I have to get rid of the 3 by dividing both sides by 3. So I get 8/3. And then I square root. Now, when you square root a fraction like this, and your denominator does not come out to be a perfect square, you are going to have to simplify it because you cannot have a square root on the denominator. You can't have any radical on the denominator. So, square root of 8 over 3, I'm going to write as the square root of 8 over the square root of 3. But again, I don't want a radical on the bottom. To fix that, you multiply both the top and the bottom by the denominator. So this is going to give me the square root of 24 over 3. Still not quite done because I have to break down the 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So I have a pair of 2's. So plus or minus. Because remember, I'm solving for x and it could be positive or negative. So plus or minus 2 square root of 6 over 3. That's one of my zeros. Or two of them technically, one positive, one negative. Now, I still have this other factor to deal with. X squared plus 2 equals 0. But this one's a lot easier. You subtract 2 from both sides and then take the square root. Now, square root of 2 is not going to simplify. The only thing I can do is take out the I because it is imaginary. And there's my other answers. Alright, so these two were trinomials, 3 terms. I'm going to do one more example with 4 terms. So, 4 terms, you group your first 2 and last 2 together, take out GCF from the first group, you get x squared times x plus 2. GCF from the second group is 5. So take out the positive 5 from both and I get x plus 2 again. If you're doing this correctly, these come out to be the same values. And because they are the same, I can pull that out as a factor as well. So I can pull out the x plus 2 and put the leftovers in another set of parentheses. Now x plus 2 is not going to simplify. X squared plus, okay, not a difference of squares. Not going to be able to factor that one further. So, now I go to the next step, which is solve. So, set it equal to 0 and solve. I get negative 2 for my first 0. So there's my first 0, my first root, whatever term you want to use. For the second one, set it equal to 0. You start by subtracting 5 from both sides. then square root, and you get plus or minus I square root of 5. Now, most of the ones I worked here where we ended up doing square roots, they were pretty simple ones to reduce. But again, if you need more practice on that or want to refresh your memory, I do have a video over simplifying radicals. Alright, I think that's all the examples I'm going to do for this. Don't forget, again, there's many skills that go along with this, like quadratic formulas, solving by square roots, all that. You're welcome to check out those videos if you are forgetting how to do them.